The LNF can process undiluted oil samples up to 320 centistokes viscosity. If heavier oils are processed, they must be diluted. If dilution is used, it's very important to filter the solvent used for dilution, otherwise they can contribute errors to the particle count itself. There's many commercially available ways of filtering solvent. One we offer is a standard accessory, solvent filtration. The container is simply filled with solvent, pressurized with a hand pump, and then when it's released, the solvent is pushed through a very fine filter, a 0.8 micron filter, which takes out all particulate below a micron. With that aside, we also offer in the standard accessories and the consumables kit, consumables that are used to prepare the solvent with dilution. So in this case, the approach would be, if you're using dilution with the sample, the straightforward way to do it after you've shaken the sample to disperse finally the particulates is decant to the second line of the bottle, and then take a syringe with 10 cc's of solvent, such as lamp oil. You can use kerosene, lamp oil, electron 22, really any traditional lab solvent to dilute, and inject your 10 cc's. Then once that's done, again, agitate the sample for 30 seconds. Once the 30 seconds has elapsed, place it in the ultrasound, again for 30 seconds, and that will remove the air bubbles. So that is one methodology of preparing a diluted sample for analysis on the LNF. After the ultrasonic, which removes the air bubbles, we process the sample on a particle counter and Ferris monitor. This test measures particle count and Ferris wear on the LNF Q230. The schematic here shows the flow path of the LNF. The sample is drawn up through the tube, through a 100 micron filter that removes large particulates, and enters the force portion of the Ferris monitor, a high density magnetometer which measures the Ferris particle count. Next, the sample enters the LNF flow cell, which uses laser light and a CCD detector to image each individual particle. This provides particle count and ISO codes, and also characterizes all particles greater than 25 microns into a wear class, either fatigue, sliding, or cutting wear, non-metallic, or fibers, based on the shape of the particles. Finally, the sample enters the second magnetometer, which measures total ferrous content in ppm. The LNF can process undiluted samples up to 320 centistokes. For heavier oils, a simple dilution can be made using the standard MiniLab 53 consumables. Once the sample is processed in the LNF, you flush with solvent. Typically use either electron 22 or lamp oil. Simply select continue from the screen. Once the results are complete, you simply select save, and again it will transfer data into AMS. The data from the 3 instruments are now recorded into the AMS Machine Health Manager OilView LIMS database. From the database, one can look at sample results.